Hey, good morning. I'm wiring everything up. I got my mic plugged in. Let's see. Just about ready to go. Get moving. Oh yes, today we're dealing with the double packety packet. Actually the buffered packets. Trying to figure out today why we're getting sort of packets buffered up. What I would like to do is first figure out the server or the client buffering these things. And to do that, I'm going to load up Wireshark. Now, I don't know if anybody's a Wireshark user here. I've used it a number of times in the past. Alright, but I think I have to do something like this for a moment. I don't have one of these for Wireshark. Let's see if we can do this. 720 Wireshark. That lowercase there. Ooh, it worked. Okay. Here's Godot. My little preview window. Okay. Move that up there. Oh, interesting. The music actually go away when I go into Godot. Funny. Let's reference. There we go. I'm going to copy and I'm going to duplicate this one. All this Wireshark, the scene. Copy the Godot editor. I'm going to paste it. I'm going to actually duplicate it. Remove the first one. Remove this one. Okay, going to rename that. Are you sure you want to rename that? Yes, I will call it. Maybe I deleted it. Copy the other one again. Paste duplicate. Oh, I did hit remove. Okay, rename. Call it Wireshark window. Double click into that and try to find a Wireshark in the little list. There we go, there's Wireshark. Wow, Wireshark is very white, isn't it? Choose loopback. Yeah, it looks like we don't have very much going on. We're going to kind of flip back and forth between those. I think I still have the server running. The server's still running. Restarted just for giggles. Okay. That's up and running. Start up the client. I'm going to get logged in. Actually, let's take that over here to reference. There we go. Some logins. Fuzzy lips, first one. Okay. let's get our filter set up for Wireshark. We want things going to a specific TCP destination, port, TCP, best port, what's that, whatever that is. It's equal to, call it 1, 2, 3, 4, 5. There we go. Basically our stream going to the server. Okay. If we look at this, so it's probably not going to show up in stream if I pop up the filter window. But basically, some of these have an actual length to them. If we find one that's more interesting, so is this going to the right server? And another question, did I start the server on that port that I'm thinking about? Maybe. Having a maybe. Cut that out of there. It's another check. Just gonna kind of eyeball it. Looking for our packets. TCP window updates. Yeah, okay. Got that. Let's put that filter back here. If I just follow this stream for a moment, follow TCP stream. Yeah, that pops up in a window. So that's the right stream. There we go. This is, you can see our little captains in here. Oh, there's Museum right there. Oh, a big list of captains there. Okay, good. We're going to clear the list, at least mark something. We'll mark that packet so we can actually see when we click what comes after it. Now we'll go into the game client. We're going to click into the puddle. So we clicked into the puddle. Let's see what we ended up sending. Okay, so this here has the 50 80s. So this is the stream ID. I'm actually a little surprised that it sent in 3 packets. Okay, that's probably something we want to figure out too. It's probably doing this because, back into Godot, this we'll want to fix right away. Because we have 3 commands for putting into this data. That we should combine these into one, and then there should be 1 packet. Let's do that real quick. I wonder if, whatever this array is, what do we have here? array. That's a pool byte array. For the stream pure buffer, we actually tell it that we want it to be in a certain mode. Right, we want it to have, we basically tell it we want set no delay. It's true. We set false there, and we call flush on it. They have a flush for socket. And pure buffer. They don't there. What about the pool byte array? Don't really have anything to force a flush there. Let's see, what about stream pure? Get, what? No? And whether it's big endian or not. And this is a stream pure TCP or a stream pure SSL, I forget which. There isn't like a flush there, so we have to be a little bit more careful about what we want to do. Alright, let's build up these streams. We'll have to do one. Right. The difference between our socket and our stream pure buffer. Socket comes from stream pure TCP. Got it. And socket, stream pure buffer. Oh, we clear it. Oh, this is just a buffer that we have. We could put all of these elements into that. Let's see what's happening here. Clear this because we're about to write a message. Alright, nailed the mic. We have our codec that we write to, so this data goes there. Stream pure buffer, we seek back to the beginning. And then we get the array out of it. I wonder if we need to go back to the beginning when we get the array out. I wonder if that's needed. What if we don't go back to the beginning? Is the array somehow different? Get data array. Methods. Set data array. Okay, that's just really no description for this property. I think it's just a backing store for this. Plus one for the type. So we end up writing these elements out to the socket instead of putting them onto the data array and then encoding elements onto it. So this pool byte array what can we write to this? If we treat it as a stream pure buffer, stream pure, we do have get and put on those. Come on. So we could do these actions on the stream peer before the encode. Alright. Oh shoot, but that's the size, isn't it? Hold on. We need to know the size of the array before we can actually write it to the... Oh, how funny. Okay, well let's seek to a certain position, leave some space at the beginning that we write to. Okay, how many bytes do we need? We need 1, 2, 3 bytes. Yeah. So we'll seek to byte 3. Do that. Seek back to byte 0. Put 3 bytes in. Hopefully that... Oh, and we need the size. The pool byte array. Move those up. Need some comments. Okay. Oh my goodness. So that... So we can build the packet. Move to position 3. We get the array here. Fill that in. Do not know if this is actually... And here they have duplicate. I'm not sure what the... So seek... You gotta understand what seek is. None of these have documentation. Most seem fairly clear. You have a byte array. You're just kind of operating over that. I kind of treat it like cursor from Rust. All right. What's a quick key for that? Go to previous. I'm not sure. We might need to get this twice. I don't know if that's actually a shallow copy or what. We'll see when we go to write it out how much is actually getting written. All right, but the size at this point is wrong because, well, we started at position 3. We had 3 extras in there. +1, -3. -3. Or the is that at the beginning? I know we could do the math there, but a -2. All right. And then we put the socket and information. The flush doesn't actually exist. All right, let's restart that. We'll see if we can even log in. No, logging in didn't work. Log in, log in, log in. Let's inspect. Log in. So stream pure buffer at this point. There's an object. Some info over here. The pool byte array. Size is huge. And it's got some pages and whatever. I'm going to clear that. Step over that. So I want to click on that again. The size is currently 0. Interesting. I'm going to seek to position 3. How much of this does it actually tell us? Not much. But we might be able to actually see the data as it drops in there. Step over this. Stream pure buffer. Data byte array again. Size, it says, is 25. But look, why is it... So page 0, and it just pages the data in there for us. Let's see. Big endian, yada yada. Okay, but if we go back to page 0, I was not expecting that we would start with, well, that information. Seek didn't seem to do anything there. Maybe we can't seek because it has no size. If we clear it, can't go to 3 because there's no 3 there. Guess we could write 3 things. We could resize. This is an interesting question. Do we get size, resize, seek? We just basically write 3 elements. Oh, and that's actually the wrong thing that we're writing to. That we want it to be stream pure there and there. Date 0. We're going to do that 3 times. I wonder what it's going to resize to, or if it just... Is it truly an array, or is it more of a vector under the hood? I guess we could go look, but stop that, restart it. All right, now if we inspect stream pure buffer, and it's full byte array, good, we have 3 empty values. Hey Carter, good morning. Impure buffer, line array. Good, now we have 3 zeros and then that. And if we go back to 0, at the array, our size, what is our size? 26. I don't know if that's correct or not for this data, I didn't check. Wasn't paying attention. Now in theory, when we put the size and the type in this, back to our, actually, is this a reference? Page 0, oh no, look, that page 0 doesn't have those values updated, so we'll have to get it again. Where's our stream peer buffer? It's pool byte array. And those values, 0, 1, and 2 are filled in now. This isn't. What do we want with this? This one, we just want the size. Well, here. So what I want to do in this case is, I really wanted to just move that down. Happy Friday, Carter. Nice day. Is there something else on stream peer buffer? Oh, I could just call get size on it. I wonder if that's going to be the correct size. Let's check the docs. Oh, that's right. Doesn't exist. You got any plans this weekend? Move that line up and toss a -2 on there. Well, that needs to be an int. There. I don't want to nerd out this weekend. That's cool. Birthday parties can be fun. Depends on the party. All right. Our breakpoint. Inspect this again. All right. So here our stream peer buffer. It's pool byte array. 3 elements in it. Great. We encode stuff to it. Check it again. Still 3 empty elements at the top. Good. Seek back to 0. What is our size? Size is 26. That does sound familiar. What it was last time, so that's good. Step over, step over. Check our stream peer buffer again. Okay, 0, 1, and 2 have been filled in. That is perfect. Now, if we get the array here, that's array. That looks correct as well. Yay, okay. Now in this case, I'm going to turn off the breakpoint. I think this code is more or less correct. All right, and supposedly that's sent. Let's see, what is our error info? Where's error info? Did I exit that function? I don't know. Yeah, okay, that's gone. Just continue. Oh, and the server returned information. That's good. But hopefully it's in fewer packets. We're playing with Wireshark today. We're going to restart. Wireshark, continue without saving. I'm going to say we want to log in as fuzzy lips, which will panic the server. Let's restart the server. Okay, restart the buffer. Continue without saving. Log in. Follow this TCP stream. That looks good. Looks like there's fewer of them now. That could be a good thing. Okay. So this one here, this is going to mark that. I know you can't see the pop-ups, but when I right click on there, I get this little menu and I can colorize the conversation and do other things. Hey, Adao. You've managed to log in, sign up matchmaking with that API. Which one is the higher API? Yes, the server is written in Rust. I need to update that panel. It's no longer using Actix. When Futures came out, I switched away from Actix and ended up just learning all the future stuff in Rust, which has been quite a nice adventure. So Actix, not there anymore. And why am I not using a higher API? It's because I need to, I really need to control the packets very tightly. So at this point, I want to make sure that each pack is kind of handcrafted. I'm using a CBOR inspired format. It's CBOR with fewer tags. So it's a really kind of tight protocol. Yeah, this is kind of the easiest way to just kind of make them both work really nicely. It's basically just TCP for me. Oh, I see. It's made for Godot. Gotcha. You know, Wireshark is not happy with me at the moment. I don't know why. You can click like things at the top, but like its little menu is just not. I have to restart Wireshark. Give me a moment. Ooh, Pinwheel of Death. All right, I'm gonna force close Wireshark. Oh. Let's get that window resized. There we go. I'm gonna go on loopback, filtering that. Restart the client, reconnect, login, and we want to filter based on our destination port. TCP dot this port is equal to 12345 at the moment. Connect, follow this stream. Okay. There we go. Now this big packet here, this one. Actually, it's gonna barf again. That is amazing. I think I found a bug in Wireshark. What if I log in? the weirdest thing. I've got Wireshark there, and there's this little menu that's popped up over Wireshark, and it won't go away. All right, I think the lesson there is don't do that to Wireshark. All right, third time's the charm. All we want to see is where the bug is for these packets. Come on, Wireshark, go away. Force quit. There we go. We back up. Not wireless diagnostics. Wireshark. There we go. Got to resize. Back to loop back. Yeah. Log in again. I do have some Rust as client side as well. I do not yet. I'm putting that off until it's absolutely needed. So when I need it for performance reasons, then I will definitely use it. Yeah, don't worry about disturbing. It's this is kind of like me learning Rust and building a game with Godot. So, by all means. Let's see. This is sequence 33. Oh. Oh. Log in. Oh shoot, I logged in as the same character twice. Okay, restarting the server, logging in again. This is cool if I see was plus internals. Yeah, it's I think a lot of people are using like the C# end because they like C#. But I'm definitely going to stick with the GD script side of things. I don't really feel a need to have that extra little payload there for that. Wireshark, why are you being such a pain in my butt today? You normally behave so much better than this. It didn't actually capture any packets. GD script with typing annotations and force will be very nice, at least for you. Yeah, I like using the type annotations. There's certain places where it just doesn't work. Let's try this again. So in this case, TCP destination, that. Log in. All right, now we have Wireshark. Some packets here. Two, three, four, five. You know what? I am picking up... Oh, I'm picking up Godot talking with the game client. That's not what I want. Oh goodness, who knew that was over, over that? Okay. How did I get that destination port, like, set up exact same thing for Godot and its debug port? That's amazing. Okay, so which one's mine? Let's see. It should be a large packet because I have a lot of actors. No, okay, here. This one will follow this TCP stream. Follow TCP stream. There it is. Alright, Adele. Thank you. So I was filtering it by port on 1, 2, 3, 4, 5. They were on the same sort of connection. Well, I guess not the same connection, but just... I don't know how that was working, actually. Alright, but in this case, let's focus on the goal. Eyes on the target. So at this point here, we're going to log in. I want to make sure that we log in and there's one packet. So here, what is this? This one here is, it's got a length of 56. Okay, I'm going to log in as Kiwi Gym. Select there. Lots of packets. No. This one here is us telling the server that we want to log in as Kiwi Gym. Here's our size, saying it's packet 0. So we're basically saying that this is the subject, and then here's the rest of the data. So the CBOR 50 is really OX40 plus 16 more bytes. So we're saying this is a byte array with 16 bytes. So from there to there. And that looks good. Okay. Now we got Kiwi Gym on screen. Let's go to the bottom of this. So at this point, I'm going to tab back over the game. I'm going to click towards the top of the island. I want to see the TCP stream numbers better. So we're on 1022. All right. I'm going to click at the top of the island right there. It didn't send a packet. That was the first click. Second click. It's too far away. Okay. I'm just going to click to the right then. There is a limit to how far you can actually let it go. Okay, click to the right. Now what did it send? Oh, it sent the subject information again. Oh, that's a server. No. Sorry, the client to the server. So we have 2 port 1, 2, 3, 4, 5. And then the server responds. Just acknowledging that. And then here we have an array of. This is packet 2. 82. We got 2 element array here. Yeah, we have data there. Server responds acknowledged. And here's your cookie. Packet 3 comes back. Okay, but the client is sending sending the packet information when it should be. That's what I wanted to check. I wanted to see where that sort of 3 packet buffer was. So was it in the client or was it in the server? But here, if I click over towards the water, yeah, it sent a packet. One more time. So evaluate, we are sending, it's packet 50 for our subject. Actually, so that's for the subject, and then send that. Why don't we send those both at the same time instead of 2 packets? Let's clean that up while we're here. Where does that happen? Let's look. So something else is probably calling write message. A couple places. Oh, I see. For every server message. So if somebody emits a server message, then that gets called. Currently our send ID packet, I think it just calls it every single time. Yeah, it's just kind of really stupid at the moment. All right, okay, that's a bigger change than I think I want to do at the moment. Let's keep on our current bug. Okay, I can disable not disable Godot. Wireshark, turn that off. So what we got from Wireshark was that client is sending 2 TCP packets, one for the stream ID, and then one for the actual data, right? The movement packet. It isn't buffering them up, it sends it right away. That's good. Close Wireshark. Yay. Now with less sharks. All right. So if it's not in Wireshark, and it's not happening in the login phase, where would it be happening? It's just because it's happening outside of login doesn't mean that it's not part of the whole stack. So, although it does seem to only happen for the actually, I don't know why the 3's there. I was thinking that maybe it's because we're sending that the sender ID stuff, but that doesn't seem to be it. I think that's kind of a red herring. This is what we were getting yesterday on the server side. Here we were sending these on the client, and that's fine. And then we send packet 0, packet 3, packet 0, packet 3, etc. There's a packet 31 tossed in there in the mix. The client wasn't logging out for some reason. I like the new packets, so we are sending fewer packets, so hopefully that helps. And we could turn on the nagling, just so we have larger packets that hit the server. All right. So where should we start with this? We could start at kind of the highest level, work our way down, or let's try to Boolean search this. I mean, let's see, where would be the halfway point on this? So we have different layers. We have, at kind of the 10,000 foot level, we have a game server. It uses a couple of libraries. It uses stream multiplexer. It also uses Tokyo. Well, I guess that then uses Tokyo, etc. Then we also have the server is also composed of game master and TCP server next, and then the client, which is what we were just looking at. It is sending the packets. It's not buffering them, so I know it's not over there. So maybe TCP server next would be a good place to add some logging. Inside of TCP server next, we have what? We'll look at TCP server next. Yes, we do have the codec. Let's start at the library though. Not too much there. It's re-exporting some stuff. Now we have the stream producer. Stream producer. All that really does is create these elements here with the wrapper around our codec. We could add some sort of inspector here. So the framed write, it wants, oh, I guess we're more interested in the reading side of this, aren't we? We could toss some sort of logger around that. Because this gets handed into stream multiplexer. So that's an option. What else do we have? Here we bind to it. We had some binding stuff. Where is our multiplexer though? Here we run the multiplexer. Incoming data TX is this series of vectors here. We could wrap those just to see what packets are actually coming out of them. Let's do that. Who's calling new on this? Server main is. And we give it these three elements. All right. This feels like it's less Boolean search and more of a top-down. This is actually very high. And what is the API on this? How do we actually wrap that? I actually do want the TX stuff. It's funny because I don't think the problem is actually right here. I don't want to spend the time yet. Bug this half of it. It would be pretty decisive. All right, here, let's just go back one. Oh, no. Come on. TCP server. We get our vectors here, /gr, reference to that. GM stream clone. Next. Where, okay, so here's GM stream. I think what we're going to see, if we start to just print out or whatever to actually the receiving end of this, let's just print that out. We'll run game master. Here, we have the incoming receiving stream. GM stream here. We run filter map on it. We could do some sort of inspect or whatever. So let's try that. GM stream dot. Oh, what is it going to be called? Let's pop in the browser. I think there are some useful elements there. Tokyo receiver. This is an MPSC receiver. MPSC receiver is a stream. Let's go look at stream ext. Stream ext in futures has some cool stuff in it. They have inspect. Does. So we can just call inspect. Will let us look at what's coming through, and we can just print that out. All right. We'll call inspect. Have our element here. We're going to do a trace, not TE error element. This is our packet. Okay, oh, we're still in the browser. Still in the browser. Back to the code. All right. So what I'm thinking is we'll do something similar to this. Stream inspect. Expected field name or number. That also returns a stream, doesn't it? It does. I need to give that a way to filter. Let filter equal that. Get in the chain there. All right. However, inspect wants a borrowed item. Syntax error expected. Field name. Oh. Format argument must be a string literal. I meant question mark there. Rust analyzer's waking up today. That's interesting. Doesn't want to go. Now in this case, I would expect that whatever the result of this inspect is still a stream. We head back to the browser, inspect, do something with each item of the stream, afterward passing it on. Inspect is also a stream and a sync. Also one pin. It's nice. So what's the big error here? Filter, it says it expected a FNB. Oh. Yes, I did that absolutely wrong. This should be GM stream. We're just rebinding that. That should be better. Okay. Okay, so at this point in the debugging, we are looking to see, are we getting 3 of these elements? Which elements are we getting, etc. Oh, not cargo watch. Build and dev run. All right, where's the water? There it is. So the server is dealing with some sort of like weird buffer. Packets are 3 behind. So we're trying to figure out where in the process is this lag coming from. This is the first place we're checking. It says just before the game master gets the packet. I'm guessing it's something like quite complicated, that it's actually being pulled through the system very slowly. I think it keeps getting pulled one step after the next through the system, but I don't understand why it only happens for or at a certain stage in the stream. So, lab back up, good, game, start that again. Log in. Now you can see both, I can't see both. There we go. Okay, there should be no logging yet. None of the new stuff. It only happens once we get to Game Master. Alright, so here we have stream connected, we got a packet, good. Now if I click, what did we get? We had this packet, incoming message ID 1. It's not super helpful. Just that it's a message, it doesn't actually tell us what the value of the message is. Element dot, what is the incoming message? That's an incoming what? That's a, it's saying this is incoming packet, a variant incoming message with the incoming message inside of it. Oh, yes, this one. We go to incoming packet. Incoming packet does have value here, so we could get the value out of it. That'll give us the message. All right. Let's see, is there anything that we can actually divine from this? We're going to click on the puddle. And that received a packet. But why did that receive packet 3? that make sense? Why is that packet 3? It should be like a packet 2. Let's click the puddle again. Find 30. Already behind. Why is that behind? Here's 3. Here's 31. 3, 30. Okay, and if I click a third time, yes. Now he runs off into the ocean. That was funny. Packet 2, yes. Okay, and there he has actually wandered back into his puddle. Okay, so where is packet 31? 31 coming from? What is packet 31? To messages lib. 31 is zone info. It does make sense that we would ask for zone information. You know, I wasn't looking for that earlier in the stream. So when I was in Godot, I thought the only way to send a packet out was through uplink. We had to call uplink write message because this was the only place that called socket dot whatever. Just doing a quick check to see if anything else is actually writing. Decode socket. Oh, write signal. Yes, for those one-off sort of packets. Basically the packets that have no data. And these are still a little chatty too, aren't they? Look at that. Because that'll send 2 packets. Let's clean that up. Oh. Okay. We should be able to use the same elements here. We'll say we're writing that. That's probably where those other elements are coming from. Write that into stream here. This one's actually much easier. And we just write that out. We'll need to get the array. Partial data, yada yada, okay. Stop that, let's run it again. All right, now can't use the same character. This is the link dead bug on the server. Let's choose one at random. Oh, Captain Spaju. And should have seen, yes, look at this. Signal 31. That's nicer. There's 30. And 3, whatever 3 is. I don't remember. Okay. Ooh, fuchsia. Let's try a different actor. His island might not have texture. We'll have to fix that later. Tiger. Oh, interesting. Is this going to be a common thing? This server panicking? Server does not appear to be panicking. All right. We'll try again. Which one do I know worked? Let's see. Which one do I know that worked and we haven't used yet? Scallywag. This worked yesterday. Interesting. I don't really care for the Fuchsia Island. That is surprising though. Why would swapping that around actually do that? Is that it being parsed as the right kind of thing? If I give it some space and I click, that's a packet of kind 2. Yes, that's a movement packet. Okay, but that's not a signal. Signal would be like packet 31, etc. I think we have some guards in place to protect against unknown packets, so if it's actually parsing wrong, that should be obvious. We'll choose Bob this time. Alright, so Bob, you had 31. There's the movement from the previous one. Back at 25. 26, he's logging in. 29. Get entity location. Okay. Connected to the other stream. At this point we have 3, we have 31. Strange. And still, I clicked and I got packet 3 instead. The client did not send packet 3. Actually, that might be a good test as well. Oh, good. Disconnect was graceful. Goodbye. Goes. Log in. There we go. We are logged in. We'll log in as Musean this time. I don't think we've talked to Musean yet. Oh, and Musean gets an island. Oh, fitting. I must have some sort of race condition on the client. Alright. Okay, but what's interesting here is that packet 3, packet 31, what is it? This is in the decode data. This isn't actually being handled yet. Here, incoming message. This here it's being handled. So we have 3 and 31. Okay. Now he's kind of on like a Mickey Mouse shaped patch of ice. In the right ear, I'm going to click. Actually, was it 31? Oh, there were some more packets sent. There was another 3 and then a 30 that were sent. Where'd those go? Okay, there's a problem. Those didn't even show up here. I just happened to notice them as I was clearing the buffer in Godot, that there was another 3 and 30. So if I click in the right ear, we get the 3. Okay, and if we click again, we get the 30. Aha. Okay, so something didn't pull this data. Why not? Because it was changed. It must have been further down, maybe in Stream Multiplexer. I'll bet that when we actually changed channels here, Stream Connected, or did something else. 6. So, quick question. If we are going back into the reader, where is this? This is in, so this is the Stream Multiplexer crate. Multiplexer does control some of the reading, but there also is Stream Mover. When Stream Mover gets put into something new, do we pull it right away? We might not be doing that. Change channel. Handle incoming connection. Okay. I think it's kind of around handle like the enqueue packet reader stuff somewhere. Run channel. It's going to be in here. We're running a channel and somebody comes to join this channel. At one point, we might get a packet out of it. So here's our packet. And say, hey, reader next. And reader here is going to be, what, this is going to be a select all or something. A marker here, line 266. So that reader, yeah, this is a select all of the stream mover with the incoming packet reader inside of it. So it's somewhere in this chain that these events aren't actually happening. I am so glad we're actually testing this library. Like actually using it. The tests did not find this. How do we simulate this with a test? It's basically I think it's incoming data causing the stream change. and then it's not signaling again. Because it went into the next queue but didn't get pulled. Oh, I see. So maybe before we put it in, we should actually pull it. So here we say, oh, the stream is connecting, but we don't bother to pull this as we're about to push it into this. I think pushing in doesn't give it a signal. So there's no reason that the select all would know that this thing has data until it signals in the future. Like when another packet comes in, I see. So we probably need to drain this thing as it's switching channels. All right, so if it switches channels, we let everybody know that it's switching channels. Then we have packet reader dot. What is packet reader at this point? So we could probably do like a try read or something on it. Doing packet reader, receive, the stream mover on a receiver. So basically we have a stream mover. So it's a stream and stream ext. Go look. Oh look, we're still in stream ext. We call next now. Actually, we don't want to wait on it. We don't want to say, hey, this is saying eventually. We want like, do you have anything right now? Peekable, what's that? Oh. Look at stream. Let's poll next. We'll return some or none. The item. Could just call that on it. Let's drive that to completion. Let's try that. Oh, we don't have context here. We could do now or never. We are in async function. Yes, we're in a spawned async block, so we can use async stuff here. Packet reader dot next dot now or never, and the documentation on now or never because I use it so infrequent. So it's going to be some or none. I see. We're going to do a while at sum on this. do we actually say down here when we send stuff? Oh, we just do incoming packet sync send and await on the send. Oh yeah. I wonder if that's the right type there. That's strange. Where's my, resize pane-x 100. There we go. Source stream multiplexer. Oh, it's an option. Expected packet found option. Oh, that's a good question. What if it is a none? Because the stream is shutting down. So if this receives none at this point, basically this case, we're not supposed to put it in here if it receives none. All right. What happens if we do push them and they're shutting down? I think we'll still get ejected, but they might never actually signal. So in this case, keep going. Shouldn't do this. I don't know if returning is actually going to be the right thing. How do I just... Do I want to just continue? Let's just have a Boolean for whether or not they should be added. Let mutable can use. Let's see, is it closed? I think that's more what we're looking for. Is kind of like this, but the opposite. So like not is reader finished, but is reader valid. It's true. And then if is reader valid. Here. If the reader returns none, the stream is complete and not enqueue them. Match packet. I think I have a formatting error in here somewhere. So I want this to be a none case. Match packet. Some packet or none. If let error. Huh. Yeah, I don't see it. 271. This is 271. Some or none. Match packet. Is this format right for us? It looks right. Expected one of those, found that. Expected pattern. Oh, I have that there. Okay. Semicolon at the wrong spot. Is reader valid? Oh, is stream valid? Yes. Consider making them mutable on 251. Yes. All right, now, so if that's... Now, what I'm wondering here is, how do we set up a test for this to actually ensure that this actually fixes this? Yo, totally not a spam bot. I just banned somebody that was a spam bot. I'm glad you are totally not a spam bot. But if you ask me if I want to be famous, I'm telling you, fingers on the button. I like this song, actually. You know what? I think he's passed the Turing test, so it's okay if he was. All right, let's see if we can make something for this. I think it's really in here. How could he be a spam bot? He's absolutely not a spam bot. Well, we all spam bots in the crazy simulation called life. Ooh, wow. Oh, wow. How do we test this? Get status. Let's do a get status on this. Oh, that's right. I also wanted. Okay, so far, nothing crazy that needs to be committed. What I'm going to do, I'm going to stash it, write the test, make sure the test fails, and then see if this fixes the test. I should have done this the other way. Stash that, get status. All right, let's go back into integration. So this is going to be kind of like a change channel test. Just snag that one. Change channel. Oh, maybe we could just put it in the change channel testing. Saw some data in there with it. So in this case, they're switching client from channel 0 to channel 1. And what do we have here? We have our TCP stream producer, and I think the TCP stream producer just does 1 byte or 2 byte, 2 byte field length. Okay. Read data from channel 0. Send 2 messages. Channel 0. Send 2 messages on channel 0. Read 1 message from channel 0. You know, I'm really glad you guys are around. It's nice. Go right to the buffer twice. Change the channel. I think this is kind of what's going on. We change the channel, and then on the next channel, we're like a packet behind now. So let's change this to, instead of A message, we'll say this is B message. Why not? It should have received A. And now, oh, look, here we have a second message. Yeah, so this should fail some stuff, maybe in a glorious way. Let's see. Argo test. By the time we get done with the game, this stream multiplexer crate's going to be nice. Wow, it's taking its sweet time. It really is. It never takes this long. Oh, goody. Okay, so change channel panicked. Oh, we didn't expect that, did we? Stream disconnected. What? Incoming message. All right, I wasn't expecting that either. 267. I'm not sure how to actually simulate this here. So in this case, yes, we are expecting that after we do a channel change, we'll get a disconnect from RX0. Unfortunately, it looks like we're actually getting... Wait, what? Getting neither? Does not match. Incoming message stream disconnected. Yes, incoming message here. Does not match disconnected. So I think what's happening isn't that the packets are getting lost to a previous stream. They're just not getting signaled during the change. Oh goodness, how do you actually test this? Like a asynchronous nightmare. Which I can reproduce very, very often. I don't know if we can actually kind of test this. Because what I think is happening is that we have multiple packets coming in. They've landed. The first packet somehow triggers the server to ask it to change channels. It's been triggered, but it hasn't finished draining that stream. Right, so imagine a stream of incoming data, right? And let's say the second packet, the first one's login, the second packet, character selection, third packet causes it to actually change channels, right? But there's a whole buffer full of data that is actually changing channels. So we read one message from channel 0. We send this. No. Okay. We're going with the big scheduler here. This might fail in other ways. I think what's happening here is because the multiplexer here, this line here is because we're sharing one thread for this test. These things can't be processed concurrently, and that's the problem. But I'm not sure exactly how I would do this in a way that... Do I need to actually add some pauses in here or something? Or some other sorts of signals? This might become a very fragile test. I don't like that. Did it stop at the same place? 267, yes. Maybe this isn't it. Let's just try using this in the game server. Because in this case, the data is going to the wrong channel. I'm going to undo here. Oh goodness, okay. Send a message on channel 0. Get status pop. Get status. Good. Right, so we have that there. Let's go back to stream game server. Now in this case, we have to give it a better path in our cargo files. So, cargo, stream multiplexer. Got a couple of them that we have to update. This is going to be path is equal to /source/stream multiplexer. Like that. Next file, paste, delete, copy, save. Do it again. Close the little quick fix list. Oh, failed to read cargo.toml over there. Oh, it doesn't like the tilde, does it? It doesn't. Okay. Segment of the tilde, CW, / goodness, users be Halstead / oh, come on, let's do this correctly, CW / users. Now with the correct spelling. Again, pop up. All right, looks like it found it somewhere else. That's good. Close that. Close that, that one, that one, that one. Wow, we got a lot of these open. Oh, did that not update all of them? What's that last one? Just a warning. Okay, stream. That one. Strange. Why didn't it catch that earlier? Cargo. Stream multiplexer. Yank that. Close. Paste. Delete. Save. Build. So if it isn't this, where else could it be? I mean, this position of the fix kind of makes sense to me in that, you know, if you had elements that still had packets, when you switch channels, when you put it in a new select all, does it actually get pulled? Like what actually happens? So if we go and we look at select all, oops, wrong one. All right, select all's over here. And this is a stream select all, not a future select all. When we push something, what's it say? Function will not call poll on the submitted stream. caller must ensure that select all poll is called in order to receive task notifications. And I think this it will not call poll on the submitted stream. Caller must ensure that select all poll is called. See, I think this here is because it's backed by futures unordered. If you look at that, be filled by collecting them or by pushing futures onto the existing set. When new futures are added, poll next must be called in order to begin receiving wake-up notifications for new futures. That's because it does some cool context monitoring. Alright. Go back to the code with the game. Alright, let's restart the game. And so far so good. Receive data. Packet 25, packet 26. Select fuzzy lips. Alright, so far so good. Got 3 and 31. I think the client actually sent another 3 and a 30. That didn't fix it. If I click, we get the 3. There's the 30. All right. So that wasn't it. Let's add some. Let's see, where would we pause some more logging in this? This is kind of complicated. It does feel like the error is somewhere in stream multiplexer. I thought it made sense that it would be when we were switching streams, because that's kind of where it happened. It seemed to happen when we went from selecting a character to having more than one piece of data come in at the same time, which is... All right, let's look at stream multiplexer again. Go from top down. Stream multiplexer has... Where's it? It's got these readers. Okay. The readers, it's supposed to be pulling these things, right? Pulling data out of these. I wonder when we do get a wake-up call, if we're not pulling that to resolution. I mean, we should be getting 1, 2, 3 packets, whatever it is. Which means that the futures, the select all, which wraps the futures unordered, should get notified. But if all those notifications get wrapped up into one thing, and we only pull it once, let's go here. What is this? Oh, that's regular run. We want run channel, I think. Kind of back to where we were. But down here, I mean, maybe it's because we're not finishing the reads here. Ooh, hey, 715209. Good morning. Happy Friday. You know, I wonder if this is actually on the wrong side of things. On some bugs. Yeah, there's this crazy bug where there's a queue, and the game client is actually getting behind in, excuse me, not the game client, the game server ends up reading packets 3 behind. So somewhere in here there's a little buffer, and trying to make sure that the buffer is basically getting flushed. In this case, and what if we had something like this over here? So when this packet signals, say, okay, well, great, we've got some data available on this packet. Now, in this case, we do not have to worry about whether or not it's valid. Bless you. Because here it just tells us that there's data. Actually, if we drive it to completion, I don't know what we do here for the none case. I mean, truly, this is just more of a sum packet. We don't push that back in. Oh, but we also didn't get the... How do we actually pull that? Can't. I think... Oh, that's so weird. Alright, no. Let's undo this. So looking at... Oh, undo some more. I'm just going to delete that. So how does this actually work? We have a select all. The select all really doesn't eject anything from it. Right? It just gets rid of things when they finish producing data. Okay. And when something finishes producing data, it just goes away. The reader gets dropped. Now in this case, saying, oh, when we do have more data, give it to me. Right? Like, I want the data so we can pass it along. And what I'm wondering here is if something in our pipeline of like our little layer of wrappers actually returning some none too early. Let's go look. This here we have a stream mover with the incoming packet reader inside of it, and that incoming packet reader is really the halt async read. So stream mover, halt async read. Go look at the stream mover. Oh, not COC rebuild, COC restart, whatever. Stream mover. Yeah, we have some tests. Now this thing is actually really simple. It's just a wrapper that might send the stream somewhere else. This is super basic. Basically, if this thing needs to move into a different channel, well, what is the purpose of the stream mover? Stream mover owns a stream. And when we need that stream to go into a different channel, you tell the stream mover, give me your stuff. Give me your stream. And the way that works is you signal, and then the waker wakes up, and you can basically eject the stream at that point. So we use probably a one-shot, Tokyo one-shot, to be able to send the stream back out of here. So this looks fairly just pass through. Like it's just not much going on here. The only other thing I could see is, let's see, I don't know, is there anything else that could be going on here? I think this looks good. Let's go to the halt side of things. Halt is a little bit more complicated. Okay. It's very, very similar, but slightly more complicated. The halt has basically the same idea behind it, in that you can halt it to drop the read half of a connection. Okay. It's also a wrapper around that stream. So we have incoming packets, you have incoming elements here. And so poll next, it'll first check to see, did our reader go away? Our reader is gone because we were told to drop it. Oh, stream's dead. Return ready none. Okay. Okay, in this case, if we are told, actually this is also very, very similar in that quick check to avoid registration if already done. We first check to see, should we be shutting down? If we should be shutting down, then we go through the process of shutting down. However, we're having this bug and our stream isn't being told to shut down, so it must not be there. Here, we're just registering our waker so that if we do have a signal that isn't based on the TCP stream, we can still wake this stream up. Okay. At this point, same thing. Did it signal between these 2 points in time? Probably not. We're not shutting the stream down. That doesn't matter. So it's got to be over here somewhere. There's only ever some here because yada yada. If we do the read, we get a value from this. What are we calling? We're calling poll next on this. We produce an incoming message from this. How does that work? Some value. What if this should be 2 things? I'm guessing that this will get called over and over and over again until it's done. But we could add some logging here. We could probably dump the data at some point. What this is actually going to do, and this here for the game server, is actually wrapping the codec and the kind of our framed reader. And the framed reader will basically take the stream off the TCP read side, read half, chunk it, and provide it here. Technically, this value should already be a packet. I mean, this code doesn't know what it is. It's just generic. That's what it should be. We should already have a stream ID. That's fine. And down here, if value is something, we do something with it. Otherwise, if there is no value, then, well, stream went away. Interesting. Let's gonna crank this up a little bit. Let's say that I have trace worn. Good. Packet. We'll just add something there just to be able to see it in the log. We'll turn that logging on. So in multiplexer, okay, we'll shut the server down. Let's just do a cargo build over there. Cargo build. It's gonna have to compile. And then edit the environment and make sure that we have warnings enabled for stream multiplexer. Debug, let's do warn. Okay. Yeah. It's nice that we have the tick going again. A long time. Can close some of these.
Are you ready?
It's almost there. All right, let's get ready. Restart the client. There we go. We still have the metric server running. I haven't even looked at that.
Are you ready?
Oh. All right, we got packet. Okay, so for 25, packet came in. 26, packet. All right. All right, and from there, how many packets we got? 29, packet. Interesting that we do see the decoder work before we hit packet. Of course, that's the case because it has to do the decoding. Absolutely makes sense. Okay. That's for 29. There's packet again. So we got 3. 31. The packet. Okay, but we didn't see another packet come in for there. Even though I know the client, I can see the client's buffer here. And just to prove it, we'll go look at Godot. Godot has also sent another 3 and a 30. Okay. So why is it that, okay, so that means that this packet, this element here, it's not getting pulled again. I think it has data right now. If we could have like something else happen in the server, if I logged in again or did something else, all these streams, it should cause that data to come out of the socket. I guess, so I don't even know where the data is. Interesting. So the problem actually with the codec and this isn't returning yet. So if we ever pull the codec, we should see it here. does feel like it's the stream here in the run channel. Like somehow using this, we're not actually getting the data out of it. I'm not sure how to tell the reader poll again, because it should just do it. We have Tokyo Select. This is for the incoming like channel changing streams. This one down here, just automatically do it. My goodness. Because at that point right there, we want that stream. We want to finish flushing that stream. So what's going on with Reader? Is Reader presuming that when it gets a signal, it doesn't have to do anything else with this? Let's look at the source for Reader. Where's Reader? Select all. Stream. It's actually not a lot of code. I've looked at it before. Select all, yada yada. So it does use the features unordered, a debug thing. So where st is stream and unpin, we'll create a new wrapper, has a length. Let's see if it's empty or not. And then you can push elements into it. And we are calling push, and it's doing this stream.intoFeatures. Basically creates a tuple, and that tuple will give it the one element and the future. So it gets the stream back out, and we'll see that down below here. When we do a poll next, see it's doing a match ready, poll next on pin. It gives us the item and the stream, basically our remaining here, and it pushes the remaining back in there, but returns the item to us. Problem I think that's happening is that somewhere in here, it's not actually polling again. It's not asking that inner thing if it's got more data, because the inner thing's not signaling again. I mean, that's my best guess as to what's happening here. But to me, it seems like we want to get the remaining, keep taking the data off of it, and maybe we change the codec so that it's an array of items. And this is just select all, utility function, etc. So let's see what happens when they push this back in. So self push remaining, that goes back in. Self.push is up above. Self inner push. Inner is a futures unordered. So let's go look at futures unordered. Stream one. Oh, TwitchCon EU got canceled. Oh dear. I have to admit that whenever anybody mentions anything about the virus, I always think of beer. The coronavirus, it's got to be, I don't know if that's good marketing for them or bad marketing. Oh dear. You got the Amsterdam badge already. Push your feature into the set. This method it adds it to the set. It will not call poll on the submitted feature. The caller must ensure that features in order to poll next is called in order to receive wake up notifications. And I think that's the rub here, is that we're not receiving wake up notifications till the next one. Alright, so I think they added some stuff recently. We look at this. Let's see, they might be a good opportunity to learn some of these other ones. Here, where's their actual site? Tokyo. I want to see their releases. Repository. And Mantula TV, welcome to the stream. Look at their release notes. Oh, Carl. Stream map. Polish. Small additions and fixes. Stream map and notify. Notify is awesome. It's like one shot, but without actually having to send a unit type. And stream map, I have not used. Similar to stream map merge, stream map supports merging multiple source streams into a single stream, producing items as they become available in source streams. It supports inserting and removing streams at runtime, which is cool. Useful cases where a consumer wishes to subscribe messages from multiple sources and dynamically manage those subscriptions. Okay, let's look at stream map. I'm a little cautious there. Stream map as. Oh, do I not have the documentation for stream map? What is there? It's under stream, Tokyo stream. Stream map. See, there's no guarantee this implementation will persist. Works with small number of streams. Okay, no. That's too bad. Probably go and use the features unordered. Basically have our own sort of reader so that we can get the element out, finish polling it to completion, and then put it back in. Oh, that's so silly. It's like one thing. And truly, I don't know if this is actually the issue. How do I turn logging on for Tokyo? Let's see. Wrong one. ENV. Oh, you know what? Tokyo trace. But I think that's going to have an issue. I don't think that's going to work. Explain why in a moment. Okay, where's the game? Reconnect. Log in. Okay, did we see any Tokyo stuff? No, no Tokyo stuff. I think it's the build overrides. Let's build it again. Oh, it didn't. It must not be that. Hmm. It's really. Let's take that off there. Yeah, there should be some Tokyo spew in there already. How do we get Tokyo spew? Full. Am I doing full? Oh, look at the feature flags here. Sync, stream, signal. Oh my goodness. What is MSRV? May increase according to the parking lot releasing. It's for tracking time. We turn on the logging for it though. Oh, you know what? But we're too late in the binding. Ah, interesting. So if I do rust log equals trace, and then have run, still no Tokyo stuff. Reconnect. Hmm. What I was thinking there was we actually wrap this whole thing in Tokyo main threaded scheduler, this element here. And later we set up the logging and the environment variables. I was thinking, oh, you know what, maybe there's a timing issue here. Maybe we needed to set it up in a different order. That doesn't appear to be the case. Well, that and our subscriber might not be the correct kind that this wants. All right, let's go see what Tokyo main does. There's some hints in there. Tokyo main. Cores, max cores. Fine, fine. Entry main. All right. Entry, old entry main. Hmm. I thought they used to have it in here. Why'd they move that? Module entry. Is that actually public here? No. GitHub, Tokyo. Tokyo. There we go. It might be in macros, but hopefully. No, not in there. Look at the lib, see what the mapping is. We want macros. Okay, yes, yes. Lots of documentation. It's fantastic. All right, let's use GitHub search. Search for main. I thought it was like entry main or something like that, wasn't it? A mod entry, Tokyo macros, source lib. Entry, there we go. Maximum threads, etc. Basic scheduler or regular or basic or regular, whatever. Threaded cores max, okay. If it's a test or not. Huh. Old. It's funny. I know I used to get like all the MIO stuff and all that. Well, logging. I must just be missing some. What is it? Tracing log? Tracing log. Am I not using this anymore? Let's add that to main. Okay. Now how do we initialize it? Look at their docs. Looks like we just do a log tracer init. Enabling the log and log always feature flags on tracing create will cause tracing spans in events to emit records as they occur. All right, right now all I want to see is the data. We call init on that. Fine. Back to the code. Server main. Install better panic. Get the environment stuff set up. That's interesting that tracing subscriber had to get updated. Oh, was that supposed to be a colon init? It is. Time to pour some tea. Got that ginger tea today. It's not just for redheads. Guess I should say people with red hair. Oh man, that is taking its sweet time. There we go. Oh look, we got MIO now. Yes, that was the answer. Oh, people already playing the game? No, not yet. Soon, I hope. Soon. I hope to be able to set up kind of like a test day where we can just get on the game and just wander around the world. Alright, so what's happened in here? I want to see like the MIO stuff and whatnot. String with polar, KQ. I don't see very much MIO stuff in there. Anything. Pull next. Oh. Oh, that's just our conversion. All of this stuff. This isn't MIO at all. Okay. We do that. What do we get? I really was expecting a lot more. There, MIO is deregistering with polar. What if we do this with Rust log trace? If we get anything more, do a couple little MIO things in there. little disappointed. I thought there would be more. Like Tokyo stuff. Really thought I would see Tokyo stuff. Feature flags, trace logger, log tracer, and env logger. Enables the env logger module, which helpers for working with env logger crate. Maybe we should turn on the env logger for that. Alright, let's try to just log in. All this stuff looks like my logging, not Tokyo's logging, etc. MIO, good, good. That's all good. Alright, so let's pretend that I didn't want to go that way with that crate. Let's say I wanted to use something like env logger. I'm supposed to have log, I'm supposed to have env logger, and then just init that up. Okay. Look, let's go back to main. Doesn't seem like it should have an issue both writing to that. Alright, let's get rid of that. Server cargo. Get rid of the tracing log. Instead, we will add env logger. Good, we have log. All right. We're just going to do a simple init here. Oh, come on. It's not a log. Okay. Let's do this at the top. Should we do that after a better panic? Probably. Hmm. There we go. Let's run it. We're going to go with trace and that. I'm going to blow up. Ah, there we go. So we got MIO. They're looking a little different this time. That's good. That should be fine. Godot. Yeah, restart you. Log in. Oh, look at that. Okay. So we are getting data coming in and out now. Some of these are just wrapping. Here, we got Tokyo Util, frame read, attempting to decode a frame. Good. Flushing frame transport, writing remaining 22. Fine. Okay. Now, this is where everything goes wrong. We'll select fuzzy lips. We should get 4 packets, right? Get clear on the Godot console. We got 29, so a packet 29, packet 3, packet 31, breathe, and 30. I mean, those are not absolutely correct, but they're what I have. Attempting to decode a frame. It's 1. Frame decoded from buffer. Okay. Attempting to decode a frame, so that's 29. Attempting to decode a frame. Where's the next flushing frame transport? Where's the other piece? All right, that seems wrong there. So here we have attempting to decode a frame, and then frame decoded from buffer. Good. Now in this case, that was our packet 29. Now we start to decode the next one. We put that at the top. Where's our next? That was 29. Our framed right. And then here we have it again, attempting to decode a frame. All right. And then nothing. So here we have kind 29. Right, there it goes. Kind 29. Logging it there. Coming through the system. 29 actually goes between 2 queues. It's expected. That is strange. So it only did like 1 frame. What, packet 29 and that's it? Where'd the other ones come from? Like, where are they? All right, let's reconnect this around. I want to see if we get different outputs. Like maybe we have some timing issue going on. Yeah, I actually clicked in there. So yeah, it must be, I don't know, it might be that stream. Yeah, the select all. I'm thinking it's the select all because the select all, when we put it back in, doesn't actually signal again. It doesn't poll again. I think we have to take care of that. All right. Does this back that up, though? Attempting to decode a frame. Validating kind. 31. Well, there's 31 coming in. We have 3 and 31 again. Oh, wait. This is too far. Would have been this chunk of data. So yeah, we had packet 29 come in. Then it wrote some data out. Attempting to decode a frame. Why would it have stopped here? From slice. Does it not have enough data? Is the length on that packet wrong? I wonder if the length of the packet doesn't actually match the type of the packet that it is. Would that cause an issue like this? Fascinating. If we look at this code here, so here when we have a signal, we only have 1 byte here. Oh. Okay. And down here, we get the size of the stream peer buffer. +1 -3. And this seems correct. Go back to 0. Check the size of it. Write the information. So let's say we wrote, let's just validate this. Set a breakpoint and run that again. Actually, login means that this works because login always works and it's a single packet. There, 1, 2, 3. Encode the data. The stream peer buffer should have 28. What is size here? Size is 26. Yes, because it's 28 plus 1 for the type minus 3 for the beginning, right? So It would be the length portion of that plus the data. It's effective of a -2, yes. That's correct. It all looks good. Validate this one up here. Oh, the server panicked. I forgot and logged in as the same character. Type is 31. Array, 3 elements in it. Looks correct. Yeah, and it is writing 3 elements. The reason I'm being a little bit more slow to make this decision is because changing how this element works, this select all works, actually going to be kind of heavy. Victor661, thank you for the follow. So yeah, if we change the select all to something else, that's a bit more of a lift. Well, we could do it. I mean, we've done that sort of stuff before. It's very, very, very similar to some of the other elements that we have in around here. I mean, it's basically just wrapping a futures unordered. Let's see, where do we use futures unordered? Multiplexer senders. Oh yeah. I mean, we might just use a futures unordered there. All we have to do is put the element back into the queue when it comes out and use, was it into stream or into future or something like that? Yeah, into future on the sender. All right, let's just swap that out. I think that'll work. We go to multiplexer and we say, this is now a futures unordered. It's going to ask us which one, I think. That's from futures stream futures unordered. A little watch there. Instead of giving readers a type. Oh, yes. It is going to ask what we mean. Oh, I did not mean to get rid of the other one. There we go. So now we have our features unordered. All right, so now line 350. Where is our features unordered? Multiplexer, line 350. Okay. Select all, goes away. Features unordered. Features unordered. Items from traits can only be used if the trait. Oh, you're in the over there, over here. Okay, now it's saying that StreamEXT might not be in scope. It is in scope, so it's not it then. Start at the top. Line 285, 285. Actually, CSC restart. Workspace symbol provider not found in current document. Okay. Well defined cargo.toml. Where does it think I am? Multiplexer. Come on, I really do want that to work. WD, stream multiplexer. LS, we have a cargo file. What is TCP streams there? Okay, that's rough from before. There we go. Now it loaded. Hopefully we'll get some diagnostics soon. What was it, 295 or so? Hey, we got some diagnostics. Goody. All right. Which function are we in? We are in run channel. When we run a channel, certain things happen. Should probably pull some of this out into its own function, like run channel incoming packet reader, blah, blah, blah. Something like that, just to pull this stuff out, this function. Self. Incoming stream, incoming, something like that. We'll give it the packet reader. Function run channel incoming stream. Mutable self call this a packet reader with unit type, because I don't know what type that is. Also unit type there. Save that, format it, good. Self value is a keyword only available in methods with a self parameter. That's right. We were not actually calling self here. We're just calling run channel. So we have to pass the state in that we actually need inside of there. Got it. What does that need inside of it? Technically, this is going to be a capital S with colon. Okay. All right, we can make that async. Now it's an async function. What else? It's not found in the scope. Okay, so we need incoming packet sync and reader. We might actually have some other lifetime issues if we do that. Let's give it the incoming packet sync, which is a what? Okay, mismatched types. Good, good, good. So in this case, when we get a packet reader out of this, what is the kind? Actually, I'm just going to say, I'm going to say, So what does a futures unordered have on it? This one here is, now the reader is a futures unordered. Fix that first. So this is unimplemented. Okay, that's unimplemented. Let's ignore that for a minute. Come back over here, fix this. Okay, and we'll mark this one as unimplemented as well. Come back to this. One thing at a time. Oh. One more. There we go. It's happier now. So in this case, this futures unordered, it should have sync on it, or excuse me, StreamEXT. If we look, where'd my documentation go? That's right, we went way off into the weeds here. Okay. So in Rust, you can see what is required for certain traits to be implemented. And here, futures unordered, on the left, there's a stream there. So if we click on stream, so what does it have up here? Iter pin mutable? What's this? Oh, that's interesting. Anyhow, that's not what we want. Stream. Stream is implemented for this. Where it's a future. Sure. Yes. So it's a stream of futures, which means that our type definition is incorrect. Let's go up to the top here where we actually define this. So this is a futures unordered. Right. We need to model this after the other place we use a futures unordered that has a stream future. I think it's called a stream future or a future stream future. Let's go look. Stream future. Oh, it is a stream future. Look at that. Stream future of the element. Okay. Oop, didn't mean to do that. So this also has a stream future. And you don't know where that is. And a stream future is returned by a call from into future on a stream. We have to do that when we push stuff into it.
All right. My wife came in.
All right, now in this case, yes. So that's going to be a futures unordered. It's going to cause all sorts of other errors, specifically where we push stuff into it. Mismatched types. What is it saying? 371? Reader there. Reader remove. Readers, plural. Self.readers.take. I see it's a run channel. We have to change the type definition here. This has a stream feature as well. Good. All right. Found packet expected. Well, expected incoming packet found tuple. And normally what it gives us back here is it's going to be a tuple with an optional element with the stream as the second thing in the tuple, so we can continue to pull from it when data comes out of it. And what line was that? 260. In fact, I mean, maybe we should just put that other code back up there. Not in the mood to make really big changes. Yeah, the formatting inside of macros is weird. All right. Yes, now we have a couple more things. I think it's more correct than it had been. Let me get rid of this function. Okay, two places where we take data out of there. So in this case, when we push the reader into there, we have to say into future. And that'll convert it into that stream future type. This packet reader is a stream, and we're converting it into a future, which is a stream future. Now at this point, when we get something out of this, get the next thing out of here. That type is quite different. Normally, well, this is really what we're getting out. It's going to be a tuple. Let's decompose this into a tuple. Packet res. And what do we call this up above? Packet reader? Okay. We match packet res. Incoming reader received none. Means it's pretty much shutting down and we should drop it. I think we're just going to drop that there. So in one case, we'll actually do something with it in the sum case where we got data out. That's done. By returning none, that's basically signaling that the packet reader is done for. It's over. So in this case, dropping packet reader stream is done. Okay. But in the case of sum, just complaining about, is it an option? Expected option found tuple. Oh, I see. No, this isn't possible because your reader is empty. We're guarding here. It'll return none if it's not, if it's empty. And we're not going to drain it. Or rather, we're not going to pull it when it is empty, so it should never return none. Maybe, was that an option of a tuple? Option tuple, yes. Which means we need one more set of parens. All right, that's not used yet because we have to put it back in there. Could not proxy channel data, shutting down receive loop. Yeah, fine. But in this case, we want to do reader.push packet reader.into future. Okay, that's good. We've converted it into a future, but we haven't actually solved the problem. The problem is that when we get something out of here, we need to actually pull this a couple more times and emit more things to this. What was it? This is very much like this up here was. We have our little loop. Let's pull it over and over and over again. There's the first packet. Packet reader, now or never. We'll get a packet out of it. If it's some, fine. None. Yeah, so yeah, what do we do if we actually reach a none? Oh, this feels like such duplication. I just want to fix the bug first, then we'll clean it up. That whole function up there is basically clone. Packet reader is not mutable. Yep. Quick fix that. Don't I have a quick fix for that? Where does packet reader come from? Oh, what is this? Packet reader. Packet reader. That was weird. I wonder if it was having issues. Mutable packet reader. That should be owned. So 292. By move pattern here. Both by ref and by move used. Interesting. My guess I could take that as a value and then if it's something, take the value. Why is that being returned as not bind, by move, and by ref in the same pattern? Those should both be moves. Yeah, I know it doesn't need to be mutable. Cannot move out of a shared reference. Alright, why is this a shared reference? Consider borrowing options contents as a ref. Let's see, so I guess I'm a little confused as to why this is a borrow. Yeah, I'm gonna go with a local variable instead. 'Cause maybe I'm borrowing it out of the during the deconstruction there. That's somehow. All right, let's say. Next reader is equal to that. So we have that. Now, just have to match that. I was just ignoring the sum case, the none case. Actually, this should just be able to take out of it. Equals next reader dot take. Reader dot next. Never call if it's empty. That doesn't need to be mutable. This one does. Remove the mutable. Really? But I want to take it. And take requires that it's mutable. Let mutable next reader equals next reader. We'll just rebind it. We own it, or rather we should own it. Yeah, okay. It has to do with the macro somehow it's producing code that isn't quite clear there. Well, that's encouraging. Let's do the tests. Good test. Testing, testing. Maybe like a little testing jingle. You need Rusty to emit some sort of audio that is catchy. But you still don't understand how to handle errors correctly. Reowning, yes. So what's happening here is this line here is getting parsed by a macro, and it's generating other code. Okay? And from what I understand, this value here I actually own. And so if I own that, you can rebind it to be mutable. Now, there's no reason you couldn't. It's you actually have ownership of it. You're not borrowing it. There's no, and then as long as you don't have any borrows against it, you can rebind it to be mutable. Well, the tests are actually taking a really long time. That's really not a good sign. Uh-oh. It's not happy. All right, link dead. It's got over 60 seconds. Socket shut down and read packets. All right, should we fix link dead first? Probably. Let's cargo watch -x test no capture link dead. And hopefully there's only one. Good. And sit there and pause. Where's link dead? That's in integration. Let's go to link dead. Let's turn the logging on. Oh, I've got like 6 minutes. Okay, let's see. Start logging. Should be able to see where things go wrong. I wonder how far it makes it in here. Well, that's just scrolling a lot. That's not very helpful. Returning none from linked dead state. Are we actually putting it back in there if it's linked dead? Yes. Okay, so I missed something here. Go back to multiplexer. Actually, there's a case in here down here, I think. So I'm not sure which one it is. But one of these is actually putting it back in, even though it shouldn't be put back in. Back it there. That's either a sum or a none. I wonder, do you think it's a loop here? Why let some packet match some? Because if that's a none, then we should hit here. And the none here, that means the now or never hit. Just run that again. It's taking a sweet time again. What else do I have going? Oh, yep, that's it. Oh, returning none from linked dead state. So it's not actually breaking out of this. Why is it returning a sum there? Oh, because it's always a sum. Sum, none, and then it loops around again. We want to break here out of the loop. Ooh, okay. Gonna be the same here then. Actually, I don't know if this code's really needed up there. Hmm. I think I do want to extract these bodies out from this branching. Yay, that actually worked. Okay, rid of that. Let's open up integration. Comment that out. Save everything. And try again. So if that works, then we can actually try on game engine. If that works, I don't know, should I push it? Should I? How far should we go with this? Going over time. I don't know. All right. All of those tests look like they are passing. And the documentation test, that one just takes forever anyways, for whatever reason. Awesome, okay. All right. Don't have much time. I'm over, so let's go ahead and get the game client fired up. Let's get it ready. It's Godot on that. Okay, here we go with all the tracing we could ever want. log in. Okay. Well, actually, it's the same so far. Now we have 29 here. Yeah, nothing changed. All right. Out of your puddle. Back to your puddle. All right. It's actually 4 now. Strange. All right. Well, that's going to be it for today. Thank you for hanging out. No, that did not fix it. Is it possible to have logging only for development? Yes. And typically the logging is very, very fast here. If you do not turn log, like if you don't have the log levels set to a certain point, it doesn't do like the evaluations and a bunch of other stuff. So things like Tokyo have tracing just built in, and you basically take no penalty if you don't have that tracing turned on. So it's very efficient, and you can control it at runtime. All right. We're gonna go visit Raimu today. I'm gonna preload his stream. I click the button. Okay, we'll get this started. He's also making a multiplayer game, online one, and he does C++ and Lua stuff and JavaScript stuff. It's kind of fun to watch. And he's got a cat. So we're gonna go in that direction. That's it. So until next time, y'all. See ya. Bye-bye.